Alrighty, back at chapter 10, thinking in objects. This is going to be a quick video, a lot of just small things to cover. What are wrapper classes and why do we have a need for wrapper classes? So as we've seen, Java intentionally distinguishes between two things, primitive data types and objects. The reason for this is that primitives are super fast. And if all your program needs is primitives, there's no need to weigh it down and slow it down with the use of objects, which would adversely affect the performance of your program. However, many Java methods, including many built-in methods, require the use of objects. So think about why that's a challenge. What if all you have is an integer, you have this primitive int, but you have a method that says, yeah, sorry, you can't use me because I require an object. How do we solve that problem and what do we do about this? The answer is wrapper classes. Java provides a convenient way for you to wrap up a primitive data type value into a given object. So examples meaning wrapping an integer or an int into an integer object, wrapping a double into a double object, and then wrapping a char into a character object, and so on. So now that these primitives have been wrapped up inside a respective object of that very similar data type, we can use these values and send them over to methods that require an object. So for clarity, if I come over here, I can just say int x equals 12, or I could say integer x equals new integer with the value 12 inside it. Let me go ahead and comment out this first one. So here I'm making this value x. What is x? It's an object of type integer. It's an address that points to an object of type integer. What's inside it? What's inside it is the number 12. So here, what I've done is I've explicitly told Java, make me a new integer object and put this primitive int value inside of it. Well, here, notice what the error says. It's not an error, it's a suggestion. It says that I am unnecessarily boxing it up explicitly. They said there's no need to do that because, in fact, if I just put 12, Java will box it up for me. But the reason I did not put 12 is I wanted you to see here, if I type this, now I'm explicitly telling Java, make a new integer object, put 12 inside it. Or if I just type this, Java will box up 12 or wrap it up for me. So this is the overall idea. So let's look at this integer wrapper class. So Java has this class called integer. I just showed you, we made an integer object. And the data that is actually stored inside this integer object is just a plain old primitive int, but it's stored inside an integer object. The value proposition is what? That we can now use this integer object and send it to methods that require an object. So here we've also previously made this myInteger class in coding rooms, and that myInteger class also required those objects. Here are other wrapper classes. We have the Boolean wrapper class, character, short, all of these traditional primitives, those 8 primitives, well, there are 8 wrapper classes. These wrapper classes, they do not have no argument constructors, right? It wouldn't make sense to tell Java, make me a new integer with no value. There are no argument constructors. You need to give it an integer. And then it's just going to tell you, hey, no need for you to wrap it up. I can wrap it up for you, Java says. And now that is gone. And what does this say here? Variable x is never read. Sure, no problem. So here is the integer and the double wrapper classes. So under the hood, we see both of them have a single data member, a single public data member that is non-static and just this variable value, which in the integer wrapper class is a primitive int, and the double wrapper class is a primitive double. We also have this maxval and minval, which are used to store the maximum and minimum possible value of an integer. Those are static variables. They belong to the blueprint. And here's all kinds of methods available for us in this wrapper class. Some of them are instance methods. these final four that we've seen and used are static methods that belong to the blueprint, that belong to the class. So you can construct a wrapper object either from a primitive data type or from a string that represents that numerical value. So here are constructors for the integer wrapper class as well as a double wrapper class. We can send over a primitive int, or we could send over a string. Kind of weird, but I could have said, I'm curious. So if I actually come right here and I say new integer 12, that will work. And let me do this. And what does it say? Remove unused. Oh, no, I don't like that. Replace with integer.value of 12. That's fine. But it is a constructor that allows us to send over a string. Just a small detail to be aware of. Each numeric class has that min value and max value. I already covered just what that means. Just to store what is that maximum possible integer, for example, or the minimum possible integer. So integer dot max val, we print this out and you're going to get the famous 2.147 billion number. That's the largest number that can be stored inside an integer. No one wants to memorize that. So Java provides it for you as a static variable. Conversion methods. Each of these wrapper classes, they implement several methods which are identified in that number class, including double value, float value, int value, long value, short value. These methods merely convert an object into a primitive type value. So here we look at these value of methods. This numeric wrapper class has this value of method where if we send it a string, it will return to us the value inside that string. We've seen this before though, but now we're seeing it officially. This method creates a new object initialized to the value represented by the specified string, which is really what NetBeans over here in Java was telling me to do. It was saying, hey, would you like to just use value of instead? Integer.value of the string 12 will give you the int, the primitive int value 12, which is then going to be wrapped up into an integer. Or in fact, I may even, let me type this, integer, I may have misspoken, dot value of, no, it does not return a primitive int. It actually returns a reference to the integer object that it's already creating. So here, just two examples of using value of. As you see, as I'm going through these things a little bit fast, because it's all pretty basic, right? This is just information that we want to be aware of. So they also give us methods for parsing strings into numbers. We've seen this already, parse int and parse double, that allow us to parse a given string into a number. Boxing and unboxing. So Java allows the automatic conversion between those primitive data types. That automatic conversion is called boxing when we're converting from a primitive to a wrapper object, or it's called unboxing when we're trying to extract that primitive data type from the wrapper object. So here's an example of boxing. If we look at this, we have an assignment on the left side. We normally start on the right side. I'm going to go to the left side. On the left side, we're saying we have an array called numbers. What is numbers? It's an array of integer references. But look at what we have assigned that to. We really made a new array on the right side of size 3 of just primitive int values. So this is an array of integer objects of size 3, but when you look at the right side, we see 3 int values. What is boxing? Boxing is where each of these individual 3 int values will be boxed up into individual integer objects and then saved into the appropriate cell of that array. That's a boxing example. What is unboxing? Well, if I have this line of code, integer I equals new integer 8, well, here we've boxed up the primitive 8 into an integer object. That's the boxing. What's the unboxing? Is what if I now say int x equals I? Well, what is I? I is a reference to an object of type integer. Clearly, I can't save that object into x. Obviously not. But Java recognizes, oh, this is an integer object. You want to save it into this primitive x. I know what you want, Java says. You really just want me to extract that primitive from inside the integer object, extract it for you, and save it into this variable x. This is the idea of unboxing. So the summary is converting an object of a wrapper type to its corresponding primitive type is called unboxing. That's the wrapper classes. That's boxing and unboxing. More little small things. Java gives us a big integer, big decimal. What if you need to perform computations with large numbers, much larger than can be held in an int, much larger than could be held inside even a long? Or what if you need very extreme high precision, more so than you can get with a double? The solution is Java gives us big integer and big decimal classes. Both of these classes are immutable, and both of them extend the number class. Just a single page on this. If you check out this example, we make a new big integer with all of those digits. We make another big integer with the number 2. Now, how do you multiply those two big integers together? You actually have to use a method that's part of that big integer object. It's a multiply method. A.multiply b will result, and it'll give you the answer to that, and then we can then print it out. Here's an example of big decimal. We can make a big decimal 1.0, another big decimal of 3, and now we can divide a by b, and we can choose to have it round up, and this is going to be our result. That's all I'm covering on big integer, big decimal, just for you to know that that's available to you. Strings, a brief little reminder about strings, that strings are immutable, right? Once you make a string object, you can't change the contents of that object. Here we have the string Java saved into the variable s, and if I then say s equals HTML, I have not changed the actual string Java because it's immutable. What I've done is I've made a new string HTML and saved that address into s. Strings are immutable, right? So we did not change Java, we merely made a new string and saved the address of that new string into s. So here is a visual of this. We take this string Java, save it into the variable s. So s stores an address of this new string object. It's immutable, it can't be changed. And now on the next slide, we see when we say s equals HTML, we've made a new string object with that value HTML inside, and we save the address of this new object into s. So strings are immutable, they cannot be changed. All we did in this example is what we changed in s was the actual address. Java also gives us something called intern strings, because if strings are immutable and we keep making so many different strings, that could give us a performance issue. If we have strings that are both frequently used, and if it happens to be, by chance, duplicate strings that are frequently used, we could have some performance impacts. To solve this, Java provides what are called intern strings. The Java virtual machine uses a unique instance for string literals that happen to have the exact same character sequence. And as I say that, I recognize that that doesn't make a whole lot of sense until you see an example, which is what we're going to come up with. But important to know this example, and these are called intern strings. So pay close attention here. We have this string s1, which equals welcome to Java. Now, as you know, we could make a new string by just directly typing over here. Let me erase this. I could say string s1 equals ASDF, or I could have said string s2 equals new string with the value ASDF inside it. Both of those make a new string, but the value is that when you do it this way without the actual new object, Java makes a new object for you. It's easier, it's quicker to type. There's no need to type new string. But I will say this also has a negative. Line 8, there's a negative to typing it, to coding it this way. When we code it this way on line 8, we're telling Java, no matter what, make me a brand new string object with the value ASDF inside, no matter what. Why do I say it that way? because of intern string. So check this out. On this first line of code, we say make a new string object, welcome to Java, and save it in the variable s1. Save the address of that object in the variable s1. Line 2 says make a new string object with the string welcome to Java right here, and save its address into variable s2. Well, look at this line of code. This once again says make an object with welcome to Java and save its address into S3. But because we didn't type new string, the way Java works is, this is called an interned string. When you do not use the keyword new to invoke the constructor to make a new string, what Java does is it asks itself, have we already created a string with the contents welcome to Java in this exact manner? Have we already created that string, which is an interned string? If so, Java says, you know what? Let's not create a new object. Let's just take that previous string and save its address into the variable S3. So in fact, you see that S1 and S3, they both point to the exact same string object because those are called interned strings. Now S2 points to an independent string object because we explicitly said, Java, make me a new string object. I don't care if you've already used the same string before. I want a new one. Well, the takeaway of that is now when we print S1 equal S2, and as you know, that's not checking the contents. That would be the dot equals method. When we use equal, this is checking are the addresses the same. And in fact, S1 equal S2, those are different addresses that would be false. But S1 equal S3 is absolutely true. So here's just a brief animation. Welcome to Java. That's that new string, intern string object that will be saved its address into S1. Here we make an actual new string object. We save its address to S2. And here we say take this intern string and saves its address into S3. So S1 and S3 are in fact pointing to the same string object. Regular expressions in Java. This is super cool, the use of regular expressions. If nothing else on your takeaway for the next 3 slides, remember that word, regular expressions. Super cool, makes your life so much easier. But in fairness, when students first see regular expressions, either they're crying or it's more of like a give up, like, hey, that seems way too complicated. So I'm going to show only a couple of simple, smaller examples. I'm going to give you these links right here to go to regular expressions at Geeks for Geeks or at W3 Schools. Regular expressions are super helpful, but also a bit complicated at times. So I'm going to show you some small examples. Here's the first example, that we can use a regular expression with these replace all, replace first, and split methods. We can actually use a regular expression. And what does that mean? Well, consider we've seen replace all previously. Consider if I have this string, and if I wanted to replace like spaces with nothing is where we've seen that used. Like replace all spaces with no spaces. That's the usage of replace all, right? Well, here if I have this string, and I say I want to replace every funky one of these characters, a plus sign, a dollar sign, or this hashtag, I want to replace any one of those with this string in. Well, here's the line of code. You say here's the string, dot replace all, and this right here is a regular expression. We have these square brackets, and inside we're saying any one of those characters, replace any one of them with n, and we print it, and here's the result. A, n, then we have a B, right? Followed by another n, followed by the hashtag, which is another n, followed by a C. That's super cool. Or what about splitting? We've seen previously how we can split a string based off of a delimiter. If we have many pieces of text that maybe are separated by commas or by spaces, we could split up that text by using the split method and tell it, hey Java, split this based off of a space. Well, now with regular expressions, what if you were given this particular string here, and we want to split it based off of any punctuation mark, a comma, a question mark, even a another comma or a period or a colon or a semicolon. Here's all of those different punctuation marks. We want to take a given string and split it based off of any one of those. Well, here's the thing. Here's the solution. You have the string dot split, but instead of splitting based off of just a single space, we're splitting using this regular expression and saying if you see any one of those things, that's how we're going to split up this string. So, and you save the result into this array of strings called tokens. I can then loop over it and print each individual string, which would be the string Java, then the string with which will have just the letter C, and then the string that has the C sharp, the string C sharp, and finally you'll have a string with C++. So imagine if you wanted to do that exact same task. If I said, given this string S equals Java, comma, C question mark, C sharp, comma, C++, and I said, I want you to extract the word Java, the letter C, a C sharp, and a C++ from that string. That would be nasty, right? But instead, if you use regular expressions and you say split this string based off of any of those punctuation marks inside those square brackets, that's a regular expression. Now, super, super cool. Converting characters and numbers to strings, this is easy. We have the value of method inside the string class. This is just something small, right? Something we've already seen, but inside the string class, I have the value of. So string dot, how about this? String dot value of, and here I can send over, maybe let's say an integer. And here I can convert the number 12 to a string. So instead of just printing it, it's kind of weird that if you had an integer and you wanted to convert it to a string, string sum string equals, we can convert the integer 12 to a string, and then we could print that string. That's what the value of does. Is it the most useful method ever? Honestly, I don't think so, because if I wanted to convert 12 into a string, I would just do this. It's a hack maybe, but I would say take an empty string and concatenate a 12 to it. That'll do the same thing a little bit quicker. But the value of, it's a way of taking a value and converting it to a particular string. And I think we're going to end with StringBuilder and StringBuffer. So StringBuilder, StringBuffer, these are alternative options to the string class. So a string class is immutable. It has that limitation. StringBuilder and StringBuffer can both be used wherever you would normally use a string, but it's more flexible. Why? Because we can add to the string object. It's no longer immutable. It feels mutable because we can add to it. We can insert characters at certain locations. We can append to a given StringBuilder object. Super cool. So here's the constructor. We can make an empty StringBuilder object. We can make a StringBuilder object with a particular string. So if I were to type in StringBuilder equals new, StringBuilder, let's just call it SB, equals new StringBuilder, and let's send over the word computer for whatever reason. We're making a new StringBuilder. It's not a string, it's a StringBuilder. What's the value? Well, it's just think of it as a stronger string, as a better string. You can do more with it. For example, check this out. If I wanted to reverse it, I can just type in StringBuilder.reverse and it'll print out computer reversed. You can't do that with a string. There is no given a string s equals computer. There is no method where I can just print out s.reverse. It doesn't exist. So StringBuilder, think of it as if you need to do cool things, bigger things with a string, you would use a StringBuilder object. So here are some constructors, and what we have on the next slide are just a sampling of some of the different methods. So now since this data is no longer immutable, we can append data to this string. We can append more contents. How about if I were to say, let's do this. Let me type sb.append, and I type in Dell. I don't know why. I'll put a space, computer. I'll put Dell, and then I'll run this. Let me print out SB. And now we have computer. Oh, it's backwards. Let me get rid of the backwards. I had reversed it. Get rid of all of that. So I have the string builder computer. Now I added the word del afterwards. It did not make a new string. That's what's cool. It's a string builder object. We're just appending to it. So really cool. We could delete components, delete certain values, do certain indices, insert into certain indices of that string builder object. So here's a string builder.append Java. We could insert HTML, and let's look at this insert. When I type in sb.insert, there's many insert methods. This is an offset. So you could say, well, from index 11, offset 11, insert HTML, and we could delete the values at 8 to 11. I'm not going to go through each one of these in detail because this is not something you memorize, right? This is something you really practice with. You would really just come over here, you make your string builder object, you append to it. Then we say, okay, well, what happens if I do, let's print this first. Let's print it. And then just play with it some. Say, what if I want to sb.insert? And I want to insert maybe what? Let's come to insert a string. At index 3, let's insert this, hello. What happens? Well, if you want to see what happens, print it. And just print out that string builder object. And what do we get? At index 3, it literally puts the word hello and it shifts everything over. So this is now cool because we can update those string objects, which makes it a lot faster. If you had a program that had 1,000,000 strings, all those different objects, but maybe a lot of duplicates, String Builder is a lot faster because now they're mutable and we don't have this issue with those duplicate strings which are being wasted in a hit on performance. So here's again some more methods. We have substring, which kind of feels like the normal string method. We have also char at the string builder object. So again, these are things that, again, you don't really, I put them in the slides just to show you some sampling, but in fact, it's really better just to come into NetBeans. I would recommend spend at the end of this video 5-10 minutes and just look through how many methods there are and play with some of them. Substring should feel pretty similar. If you wanted to print out right now, what is sb.substring at index, no, not subsequence, substring at index 2. Let's do index 1. What's going to print? Well, it should print out the previous string starting from index 1. That's like a normal substring, right? Or if you said, okay, well, what happens if I print out sb.char at? How about the char at index 6? Well, what's going to get printed? Let's run this, and it prints out L. And in fact, if you were, it prints out L, right? Which is 0, 1, 2, 3, 4, 5, and index 6 is an L. So that works pretty similar to what you've already seen. So what I recommend is just to come through and to mess with some of these methods to get an appreciation for some of these methods that String Builder allows you, how it allows you to modify the data, something that you can't do with a string object. And guess what? As I said, this was going to be easy. This was super easy. Nothing in there, oh no, I still had that on the entire time. What a fail. I love messing up. It's all right. But nothing here, super hard, a shorter video, just with some small things. String builders, whatever else we covered, intern strings, other components. We did a little bit of math previously. What was this? The idea after the strings of this regular expressions. Small things, each having an importance, but nothing really major that was new. So play with a little bit of that, ask questions, reach out. It's been fun. Take care, everyone.